Greetings to all. Today I am going to introduce you recurrent neural network, commonly known as RNN. Our topic today focuses on how deep learning models process sequential and temporal data. Unlike transfer neural networks, RNN achieve this by utilizations and internal hidden memories. Let us try and understand how they work, why they so powerful. Before we look at the math or core, let us talk the core philosophy of sequential data. Why we do need to new type of network, why they can't we just stand for new networks we already have. The answer lies how the experience of the process in the world to continue sequentially where history matters. To understand this, let's look the simple analogy. This about how we need to sentence. Your brain does not evaluate each word as isolations. When the when they read the word networks its presentation titles, you understand this context because they remember the neural network that come right before it predictions for the next word. Analyze the always depending on the entire history of power word before it is. Now, let us take three main pillars of the fundamental units of the network. They contain hidden states, the cycle back to input for the next step in. Second is RNN unfolding. This is the a computational visualization of the network by unrolling the loop over the length of the input sentence. Finally, we have the back propagation through time, or PPT. This is the mathematical algorithm we use to train the network propagations errors and backward the unrolled truth or our unrolled flowchart of optimization the weight. So let us take the actual mathematical under the hood. Don't worry, it is quite interesting. Point to point first formulas is h of t is tan h u point h of t plus u w point h of minus t plus b at any time step as the t. The current hidden memory state is h of t, and update the using the combinations of two things. The current input xt scaled by weight matrix is u, and the previous hidden state is h of minus 1. The scaled weight of matrix is w. We add the biasing the term b and apply the non-linearing the activation functions, usually tan. Now, does the network learn? Since our calculations is step 3, depending on the happening, the time step 2 and time step 1, our errors also cascaded backward truth. Mathematically, to calculate the gradient of the losses respect to our weights, we use the chain rule across the all preceding state. One of the greatest features of RNN is their flexibility. As you can see this table, we can structure the multiple way of depending on our goal. First one to many, and many to one, and many to many. So one to one, this takes single input and to generate the sequential output. The many to one, here we feed a sequential input, they get one single output. So next, the third one is many to many. This maps sequential of input and sequential of outputs, which gold the standards for machine analysis, and like translating the English sentence to Tamil or French. Might stand for vanilla RNNs are elegant. They are face of massive engineering problems when sequential get too long. In this next sessions, we will discuss the advantages of the variant design and overcome these memory's limitation. The major bottleneck of simple RNNs, the vanished gradient problem. When the sequence is very long, the repeated mathematical multiplications during the training cast the gradient of string almost zero. This means the model of completely forget to information for earlier steps, making the blind to long-term context. To solve this, researchers including the LSTM or long-term short memories. So LSTM is introduced to dedicated highway-like cell stage regulated by three units. First one is for forget gate, input gate, the last one is output gate. To summarize our architecture's choice, let us look the complex table. Vanilla Rn, it is used for simple recurrent loop. LSTM, it is used for complex setups with cell stages, thus gates. GRU, gated recurrent units. There are extremely versions of the LMST. For those interested in the implementation, this practically the here simple implementation using TensorFlow and Keras. We started the building sequential model and we add to simple RNN layer with 50 units define of our input shape and use the RLU activation functions. So point to second code block. Finally, we compile the modeling using Adam, optimizing the characteristic cross entropy loss and call to train to our sequential data with just few lines of codes. We have the sequential predictions of the. Thank you.